In this section, we're going to be looking at compound inequalities. The easiest way to describe this, for the most part, is that you have two separate inequalities, and they're going to be joined by one of two words. Either the word "and," which indicates an intersection, or the word "or," which means a union. So let's make sure we understand the difference between intersection and union. So when we talk about an intersection, so you will only include solutions that are common to both inequalities. So when you have the word "and," you can only include those values that work for not just one, but it has to work for the other guy at the same time. It's got to be in the intersection, okay? An easy way to think about this, if you go back and think about those Venn diagrams that you would have done a long, long time ago, right? In a Venn diagram, you would have something kind of like this. And oftentimes, we're concerned with what's in the intersection. And so this little part right here is your intersection. And where those guys overlap would be values that are true for both section A and section B. And so that's what you would put in the intersection. The word "or," though, means something a bit different. So "or" means union. And with union means combine all solutions together. And it's not only combine those guys that are true for both of them. If it's true for one or the other, it doesn't matter. So these guys don't even have to be connected. An intersection has to be connected. There has to be some kind of overlapping area, not for a union. Okay, so let's take a look at a couple of these so you can get an idea about the difference between "and" "or." So, for example, if we need to solve this compound inequality, that x is greater than or equal to 9 and x is less than or equal to 51. The key word here is "and." And that word "and" means that we are looking for the intersection between these two solution sets. So a nice, easy way of doing this is something very much like what we have here for that Venn diagram. So we can take our number line and we can put on the numbers here that we care about. We care about 9 and 51, making sure that we pay attention to the correct order here. So I'm going to do this. I'm going to take this pink guy right here and show greater than or equal to 9. I'm going to do it not on the number line, but above it. So greater than or equal to 9 means including 9 going all the way to the right. This is how you would express that solution set for x is greater than or equal to 9. And then I'm going to take this light blue color and do less than or equal to 51. So that's including 51 and then just going all the way out to the left, like that. So this is x is less than or equal to 51. But for the intersection, we're looking at where do these guys overlap? What do they have in common? Where is that intersection, like what we have right here? Well, the intersection is going to be this section where they have shared values, shared ideals, really, you know? And so it's that region in between. So it's that region in between 9 and 51 that they have in common. And what about the endpoints? Well, you see that we are including 9 here and here, so this guy gets to be filled in. And we're including 9 here and here. So both of these guys are filled in because they both have the equal to part for that for the inequality. So your interval notation is going to be bracket 9 to 51, just like that. Now, suppose for a moment, suppose that this had said x is greater than or equal to 9 and x is less than 51. What if I drop the or equal to part? Well, they would still have the same intersection here in the middle. The only thing that would be different would be the endpoint. So instead of this guy being closed like it is here, it would then be open. So you would still have from bracket 9 to 51, but then 51 would have parentheses on it. That's the only difference, and that's what we're going to see a lot with these inequalities. It's all about finding those key critical values and knowing which way to go. The inequality is really just there to tell us which way to go and if we're including that value or not. But we still have to do the math to get to that critical value. All right, let's try this. Let's try x is greater than 6 or x is less than negative 4. So the key thing to understand and see here is that we see the word or. And the word or means the word union. And as we mentioned at the top of this page, union just says put it all together. Whether you work for one or the other, I don't really care. It doesn't have to work for both. That's not crucial. When it's and, the numbers have to work for both of these guys. So any number that you pick in this region, suppose the number 20, 20 is between 9 and 51, 20 is greater than or equal to 9, and 20 is also less than or equal to 51. So that's why it's going to be true. For a union, I just have to put everything on the number line and describe what I see. So I've got 2 points that I care about, 6 and negative 4, and I've got to put them in the right order for the number line. So negative 4 is over here, and 6 is right there. So greater than 6 is open at 6 going to the right. Less than negative 4 is open at negative 4 and going to the left. Now the reason it's open for both of these is because neither of these inequalities has the or equal to part to it. Now, if I were to ask you where do these guys intersect, you could say they don't intersect anywhere. They're going in opposite directions. But I'm not asking for the intersection. I'm asking for the union. And that means take what you see and describe this using interval notation. So this piece right here is coming from parentheses, negative infinity to negative 4, parentheses because I'm not including negative 4, and anytime there's a gap, you use that union sign. We pick back up here with parentheses and the 6, the parentheses indicating that we are not including the 6. Going all the way to the right without stopping, that's toward infinity. And so that's what the union would look like for this example. Okay? Now let's see some weird things that may happen, some extra special cases, and a nice, neat way of seeing an intersection.